Where's my intro?
You can never really
Welcome
hear.
back to the channel.
I can never hear myself when I
An A. What is sigma notation?
listen.
So it's just basically another way of saying add up all the numbers. All right. So if I were to give you this one, so if I said Sn, what does that mean now? You should know. So that is the sum, spelled completely wrong, the sum of n terms is Sn. Okay. We can, I'm just taking it from the book. We can say, those of you that are used to using Excel will recognize the sum of symbol. And then we can say consistent. R equals n. R equals 1.
So n equals
So n equals 1 in this. And in this case, we now need to say the sum of what? So this means the sum of the first term all the way up to the nth term. All right, if we keep it simple, we just say you are for a very basic case. So what does this mean? Well, this means we're going to do you are starting at 1, and then we're going to add u2, u3, u4, and keep going until we get to whatever's specified. What are you looking at, Massey? Okay. So just taking it straight from, this is quite a simple thing, so I'm going straight to the exercise. Exercise 4b, let's have a look at question 1b II. So we're just interpreting what it says now. We've got r equals -1 to 4. And we've got 1.5 to the power of r. So how would we evaluate that?
So how would we write that out?
Yeah.
So that'd be 1.5. Where you asked me.
True, Ed. Come on.
1.5 to the power of
Yeah.
minus 1.
1.5 to the power of -1.
Plus 1.5 to the power of 0.
Yeah.
Plus 1.5 to the power of 1. Plus 1.5 to the power of 2. 1.5 to the power of 3. Plus 1.5 to the power of 4.
Yeah. So these short ones, you could just evaluate that. Use your calculator. So if I ask you to evaluate, I'm asking for what all of that equals. Yes.
What happens if it's just like a massive number?
So
Do you use a formula?
yes, we're going to have a formula for doing the sum of different types of sequences.
If it was
Not a limit. Well, limits come into it, but it's not.
if it was r minus 1, then it was 150 at the top.
Yes, we would need a different way to do it.
Okay.
So it's kind of simple enough. Let's look, because it's a slight difference, 1c part I. So we've got the sum of b, a plus 1. We've got a equals 4 and a equals 1.
We're going to be asked to find.
So what is it?
B times 1 plus 2, 1.
Which is
B1. The 1B. Yeah.
1 plus 1 is,
1. Oh, no, 2, sorry. Not about time.
so 2b plus
B times 2 plus 3, so 3B.
3b plus
4B.
4b
5B.
plus 5b. Okay? And what does that simplify down to? 14b. and that's it. Okay. So we weren't given anything for B in that case. Reminds me, I did want to go back to the previous question from last lesson. We'll do that towards the end. So how does this work? So we're going to have the natural log of 3
Yep.
plus
2,
the natural log of
3 squared.
9, yeah, 3 squared. Should we leave it as 3 squared? And see you know why. Plus the natural log of 3
Oh, then you
cubed.
take
It's about 4. That's the natural log of 3. It's about, Right. So I think like a couple of you have already spotted. You would then say, well, that's the natural log of 3 plus 2 lots of the natural log of 3 plus 3 lots of the natural log of 3. Okay, which will be 5, 9,
15.
12, 15 times the natural log of 3.
So 19.
Yeah, wait. It's that added up wrong.
Okay. I'll leave you to do one yourself. So I need another exact value of k equals 1 to 6 of the sine 60.
Is it 0?
I don't know.
Uh,
So look, so we've got obviously the first term is the sine of 60 plus the sine of 120 plus the sine of 180
Yeah,
plus the sine of 4 plus. So what did you evaluate these to be? Sine of 60 is 3 over 2 plus root 3 over 2
0
plus 0
minus root 3 over 2
plus minus root 3 over 2
minus root 2
plus minus
plus 0.
and then a plus 0.
So
The way you put it in yourself.
But you
Okay.
have to already
it's
spec-
0.
So adds up to 0. Cool.
I also have to put in that calculator.
This one, by the way, take note of when it says exact values. Because obviously, if you tried to do that using decimals, you're not going to get the correct answer right.
So you have to use the
All right, that's it. That's sigma notation. I guess I will. It doesn't come up in the book, but I will kind of mention one thing to you, which is, if I said to you, what's the? I think the sum of. We can start where we want. We don't have to start at 1. We could start at 3 and go up to 25, for instance. All right. And sometimes starting at 3 and going up to 25 of whatever this function is the same as starting at 1 and going to 22 of a different function that might be easier to work out. All right, so a little note there.
What
Yes,
do you do when like r equals 1 and the top one is like 1,500?
that's what we're about to look into. So what we will eventually do is we'll go even further than that, which is what if r is 1 and we go to infinity. That's something we'll also look at. And this is called the sum to infinity. All right. So we will get to that point. But first of all, we're going to go straight on to, well, how do we just add up? You've already done it, arithmetic sequences. So like you're saying, what happens if we've got an arithmetic sequence and it goes on for a long time and we're going to be asked to add all that up? All right. So we're going to do the sum of an
What is an
Arithmetic.
arithmetic sequence?
series. So an arithmetic one, does anyone want to tell us? Arithmetic means it goes up in a linear way, adding every
Oh.
time. Add the same thing. All right. So we're going to get to this point, but first of all, we need to. Actually, I'm going to skip a couple of things. Let's go straight to the sum of it. Let's see whether we can get there anyway. So basically, we're going to do worked example 4.8, which is page 73. So we've got a question which is find the sum of the first 30 terms of an arithmetic, also called progression is another word that they use for it. It's an arithmetic sequence progression. But we've got with first term 8 and a common difference of 0.5. So it means it goes up 0.5. Like it starts at 8 and goes
8 and
8.5 and so on. Okay. All right. How do we go about that then? So that first question I gave you, by the way, is a question like this. Right. So the first term, U1 is 8. U2 is 8.5. And so on. So we're going to do 8 plus 8.5 plus 9 plus 9.5 and so on. What's different to this one is what's the end point?
30th term.
So we need to know what U30 is, yeah. But we haven't been given it in this question. So before we can add up using that method we did before, what do we need to know first?
How many terms are?
We know they're 30.
Can we just add?
It's just the something and also
So we need to figure out what the 30th term is, yeah?
Can we just do 8 plus 15?
That is for one, so.
Why 8 plus 15?
Because every step is 0.5 and we have 30 steps. So.
Okay. So you may well have. So U30 is going to be 8 plus
15.
15, or
8 plus 30 times.
0.5
is it
and
going to be 8 plus 15?
0.5 and
Well, let me just ask you that. Is it going to be 30 lots of 0.5? I know it's the same thing, but is that correct? Do I start at 8 and add on 0.5 30 times to get to the 30th term?
The first term is 8.
Yeah?
Yes.
Yeah, that's fine.
yeah, so that is what you did.
Is it?
You start at 8 and add 0.5 until you get to the 30.
Yeah.
Yeah.
Yeah, no, I'm not disagreeing. Is it 30 times?
29.
Until you-
Yeah.
29 times, isn't it?
Yeah.
Because you didn't add 0.5 to get to the 8 at the first term. So we actually only add 0.5 to start with the second term. So only 29 of the terms have the 0. So we have here, yes, go on.
So,
Well, obviously, yeah, because that was the same thing as you put. So yeah, we'd add up. Now, what I want to do, however, is I'm going to generalize this, which is UN would be, well, what have we done here? We've got 8, which is the first term. We could call it U1 or A, plus,
N times 0.5.
well, it's N minus 1, remember?
Oh, yeah.
Yeah, because it's 1 less. And the 0.5 is the common difference, and we call that D. C for difference. Okay, I get. And that's A. The first term is Ed. So we've got n minus 1. So that's a general rule for finding a term in an arithmetic sequence. Now, you may well have in the past used the mx plus c approach. It goes up by 0.5, so it's 0.5n, and that also works, but this is kind of the general approach. Now, what is this then? What's the 30th term?
22.5.
22.5. Okay. So we've now got the last term here, and we've got the. So we went through a method earlier on in the lesson, how to add up a list of numbers that goes up like this. So what do we do? You remember?
Yeah.
It literally was 16 minutes ago.
Just do
So we're going to do the
22.5.
sum of 30 terms is
8 plus
8 plus.
8 plus. One.
How did we do it? We wrote it, so the sum of 30, and then we wrote the sum of 30 backwards, which was 22.5 plus 22 plus.
Yeah.
So what does that add to? So it's not going to be, it's going to be
No.
8 plus 22.5 times 30
Oh,
over 2. If I do a half times that, because I know what's coming. That same thing.
Is that
So this term, first term plus last term,
is that equal 2020?
okay?
You-
Get why we did that? First term, last term. There are 30 terms in this one. We didn't have to work that one out. There are just 30 terms from that. Okay, so times 30. But we only wanted half of it.
30 times 30.5
30 times 30.5,
divided by 2 is
Divide by 2.
457.
457.
But didn't we just get 2020? 22.
No, we got 22.5 as the final term only. I want to know
Oh, it's a
what
sum now.
adding them
Oh,
upwards. Yeah. All right. That should lead us to now a formula for the sum
for the sum.
of n terms of an arithmetic series. A
Uh,
half,
First term plus
first term,
final term
plus final term.
times n.
Well, I'm going to rewrite it in a sort of an IB way, which is u1 plus
U30.
un
Times n.
times d,
What would D be?
the difference. Yeah, the common difference. So that's what we did here, yeah? U1, U30, n.
UN.
Where's the
Sorry.
D then?
So it's not d, is it? Sorry. I'm using myself because I'm thinking of the next thing.
So it's N.
So it's n.
And it's-
Okay. So in A-level terms, and IB as well actually, the formula can also be written as, and we're going to simplify it, A plus, well, how do I find the UN? Well, I've got this. A plus n minus 1 times d. And how can I simplify that? Well, Sn is a half times 2a's plus n minus 1 lots of the difference.
And that's just the same.
And it gives you the
I
same
feel like
thing.
the second one that IB was using.
But you need to
Well, no,
know
you need them.
UN.
So, this actually, I hope you're happy. I can rewrite this as Sn is n over 2 u1 plus un. Okay, so we've got two potential formulas, and it's Sorry, I kind of led you a little bit. It's not A level IB as such.
We still need an n at the end of that equation.
Here?
Yeah.
No,
Where-
because this one, look,
oh, n's in
this
the-
whole bit here is for UN. Yeah?
But in the other question, we're still
We've
doing
got the N in
UN.
here, look.
But so we don't.
Because
we have
this
the
is
n
gonna
in
be the
other
30.
equation as well?
No, because this one is first and last, but we need to know how many terms it is. This one here, you put the number of terms in it to work out what the final term is. It's already there. Yeah. First term plus last term. So this is U1. Last term is this. That's just a replacement for saying that, isn't it? No, I think you are right. I've missed it. What did we not do? This should still be
N over
n over 2, shouldn't it? I misunderstood what you said. This should still be n over 2. Sorry, guys. Because we still have to say how many terms we're adding together, don't we?
Oh, no, bro.
Sorry.
Rewrite the one as
So in this case, you are given the first term, you are given the final term. You're told how many terms there are in several ways. In the first question, I want you to see the difference, which is you're given that it is an arithmetic progression. You're given the first term, but you're not told what the final term is. You're told that the difference is D. So you can work out what the final term is going to be.
You're down
Okay.
against the.
So I got 30,000 watch. And I just wrote that into my calculator.